I was just saying that if I start out with some parametric equation, here my x is equal to the sine of some parameter t, my y is equal to the cosine of that same parameter t, then I can square both of those up, add the squares together, and I find out that x squared plus y squared has to equal 1, which is the equation for a circle with radius 1. So I can figure out what shape my parametric equation is tracing before I even look at it. I can just look at the formula of this parametric equation. So let me change this slightly. And I'm going to disable the drawing before I look at it again. What should happen if instead of these choices of x and y, I had 2 times sine of t as my x coordinate, 5 times cosine of t as my y coordinate? Let's think about that. Well, I would want to write these out. X is twice sine of t. Y is 5 times cosine of t. And to understand what's going on, I would want to square these and see if I can add them together. So my x squared I know is going to be 4 times sine squared of t. And I know that my y squared is going to be 25 cosine squared of t. If I add those things up, they're not going to cancel the right way. Yeah, that's not going to work here. What I need, what I want, is I should be able to add up a cosine squared and a sine squared. Those are the only places where I have a t involved in these equations, and then adding those things up, it doesn't matter what value t is. So I'm going to divide my x equation by 4 on both sides. And I'm going to divide my y equation by 25 on both sides. And I'm picking those numbers because I want the right-hand sides of these equations to just be sine squared and cosine squared. And I know that's going to work now because in these fractions, I'll just have cancellation. So when I remove the parameter here, when I try to get an equation that relates my x's and my y's, I would get x squared on 4 plus y squared on 25 equals 1. Once again, I have managed to do it. Now, what shape does this make? You might recognize this equation from a class in geometry. This is an ellipse. But is this ellipse stretched more in the horizontal direction or the vertical direction? Let's see if we can figure this out. What values of x and y actually make sense in this equation? Or another way to think about it is what values of x and y can come out of my parametric equation up here. So if I think about this, in terms of the Cartesian equation, the rectangular coordinates here, if I ignore this x term, the very biggest that y could be is positive 5. Any bigger than that, and this equation won't make sense anymore. I'll have a number bigger than 25 divided by 25 equals 1. Can't have that. If I ignore my y, right? This is just some positive thing that I'm covering up. The very biggest that my x can be is positive 2. So x can be as large as positive 2. Let me make a mark of that right here. And the least that x can be is negative 2 for the same reason. When I square this, right? I could get something, I could have a negative number squared, but then that'll just be positive. So there's my x's here and here. And my y's can be between -5 and +5. So I'm expecting an ellipse that fits in between all 4 of these marks. So an ellipse which is stretched out vertically. Do I see that when I turn the plot back on? Yes, I do.